Hi. Today I'm going to work on a little project which I'd like to call Feed Ollie or Folly. So basically, Claire and I like going away for the weekend every now and then, but we have a very little creature named Ollie who likes food, so he needs to be fed. Now there are some solutions to that problem. We have an automatic cat feeder. The problem with this particular feeder is it has a single timer for the interval between openings. Now, the issue we have is sometimes we want to set it so that it'll feed him, if we leave in the morning, it'll feed him at night. But if we set it for like 3 hours, then it'll open in 3 hours, but then it'll open again the next 3 hours, which is kind of the middle of the night, and then the next 3 hours. So it really ties us down to when we set it in the first place. Otherwise, we kind of want it to be 12 hours so that it feeds him 7 in the morning, 7 at night, 7 in the morning. So a small limitation, which we can get around, but what's the fun in that? So I am going to make a few changes. I will open this feeder, and we can take a look at how it works. And a little trick here, I have actually opened it already, so I kind of know how it works. And I've noticed a little solenoid that opens the bowl we can trigger remotely. But I might have to do a little bit of soldering, and I'm going to use my trusty little Raspberry Pi for that. Okay, let me open this up, and then I'll show you how it looks inside and how we can achieve that. Cool. In short, it works like this. You wind it back, it has a spring-loaded action all the way. There we go. And then you put the lid on, and well, you obviously fill it with food first. And then you put the lid on and lock it in place, and then you set it for the interval. But they've given us a handy little button here where you can push the button and it will release. If I can tie into this button, I can make it release when I would like it to. I'll show you this quickly how it works. There we go. And then there we go. Solenoid still goes, but it obviously doesn't have any more bowls to go around. I'll open this up and then we can take a look. But okay, so as you can see, it has a spring-loaded swivel thing and an arm that hooks the turning thing in place. And there's a little solenoid here that releases this, and then as it turns, it hooks again. So every time you push the solenoid, it lifts this lever and then allows it to rotate and then hook again. The little solenoid there is controlled by this little microcontroller. Now, there's a power supply where the batteries are, a switch, the little solenoid, and obviously here's the microcontroller. Now, what I need to tie into is this little button. So if I can solder something onto this button and effectively push this button whenever I like through the Raspberry Pi, and I'll use these GPIO pins for that, then I can set a timer electronically using the Raspberry Pi. So that is the plan. Now, I don't want to destroy this in the way that it works. So my plan is I've got these little plugs, which are actually power plugs. Just bought them online, but they will do the trick. So I'm going to put this here and connect these to that switch. So the idea is, if these two get shorted out, it'll trigger, it'll turn. Then on this end of this, I can take those wires and basically send them to the Raspberry Pi's GPIO ports. The problem is, I don't want to run it directly off of the GPIO ports because they provide power, and really I just want to close the circuit. Also, I want to segregate between this system and this system. So to do that, I have a little, well, I only need one of them, but I've got a little relay block, and the Raspberry Pi plugs into that, and then I can put these wires from here onto this relay block, and then whenever I send a signal here, the relay block shorts these two out, which then effectively pushes the button, and then this will rotate, which will be the plan. Then if I unplug this and use this system separately, this is still open, which doesn't interfere with the system. I can still push the button and everything else still works. So I can still use this without, changing the way it works. Okay, let's start opening up this and see what we can do. And now we can separate that whole thing. There we go. We have it open, and now we can see where the button is that we need to press. Before I solder these on, I'm going to have to make a hole here first so that I can feed these wires through and potentially even mount this plug, and then these wires should go around there quite nicely. Okay, now I've got my trusty drill. Just need to get the right size drill bit for this. There we go. Perfect. That in nicely. I just need the nut that goes on the other end. But before I continue, I need to clean up this mess. Okay, now I can solder these onto these two pins. Okay, now that looks good. Okay, let us plug everything in and see where we are left. That's great. I think now we can just reassemble everything, and we're good to go. Okay, let us reassemble everything. Turn it on, it looks good. Button still works as we expect. And if we short this out, it works. Brilliant. Okay, now we have to do this part so that we can connect it to the Raspberry Pi. Okay, just going to solder this on. So I've already tinned these ends. Should be able to solder this on. Okay, so I've got these soldered in now. I just need to crimp the top here, and I'm going to put a little bit of tape in between them because they're quite close together, these contacts, just to keep them separate. Okay, now that that is done, I've got some of these breadboard cables so that I can female to female type and be able to connect them to the GPIO on here and onto the inputs on here. This will trigger the relay, and on the other end of this cable I'll be able to screw in these contacts here on the other end of the relay. That's good. I shouldn't need the soldering iron anymore. Everything else now is either screw in or plug in, and then I need to write some code for this. Okay, so I'm in the office. I've got the Raspberry Pi plugged into this monitor. I don't remember all of the GPIO pin numbers, so I've got a diagram here on my laptop. Okay, so I'm going to wire up all of these relay switches to the GPIO pins. I only really need the one, but it's just I'm going to be using this again soon, so I might as well wire them all in. I'll tear these 6 off, and I will begin wiring them up. So this leaves our connections looking like this. These ones all in a row. Power on this side, ground on this side, all of the inputs there. And then on the Raspberry Pi, we've got the power on the top right, and then we've got skipping one there. We've got 2, 3, 4. Then ground, then 17, all in a nice line. Okay, so we should be able to connect up. Our Raspberry Pi. There's a monitor. I've got a wireless keyboard and mouse connected there. And now we can give it some power. And there we go. Get it to boot up. So once you've booted up into your Raspberry Pi, you need to enable the GPIO pins. So to do that, go to the main Pi menu, go to Preferences, and Raspberry Pi Configuration. Once the configuration opens, you can go to Interfaces, and then make sure you've enabled SPI, I2C,
and also remote GPIO. Make sure these three are enabled. You may have to reboot once you've changed that. So I've written a short Python script, and basically I set the mode for board because I'm using the board pins. I set some pins as outputs, and then I'm using 11 just to turn on and turn off, and then I do a cleanup, and that's all I'm doing. Our relay should light up if I run this. Run module. There we go. Turned on for half a second, which is really all we need for that to work. Now we can try testing it out for real. Run module. Hey, it's working. Perfect. Happy with that. Next we need to write some code that will allow us to schedule times for that to happen. But we've basically accomplished a nice remote way of electronically switching that on.